Hello and welcome back. This video will be on Section 5 of the Prerequisites chapter, specifically on factoring. And factoring is going to be when we're going to write a number or an expression as a product of smaller expressions rather than as a sum of terms. So for instance, maybe we look at the expression 10x plus 10y, and maybe this is easy to understand, but depending on the situation, maybe I would rather write 10x plus 10y as 10 times x plus y. Depending on the situation, maybe this is a little bit easier to use. So for instance, if we want to divide this by something, it's nice to know what all of its factors are. So when we want to factor expressions, it's important to understand what a common factor is. So a common factor between two things, so here I just have two numbers, 20 and 30. We want to understand what are the common factors. And for the moment, we're not going to worry about the number 1 because 1 is a factor of everything. So for instance, 20 is divisible by 2, 20 is divisible by 4, 5, and 10. It's also important to remember that everything is divisible by itself, except for 0. We can't divide by 0. So 20 has these 5 factors that aren't the number 1, and 30 has what looks like 7 factors, 2, 3, 5, 6, 10, 15, and 30 itself. So what's often useful is to find the greatest common factor, which is going to be 10. Common just means common to both of them, as in they both have the same factor, and 10 here will be the greatest common factor. So let's look more at some specific examples. Here we have the expression 20 times x times y plus 30 times x squared. Well, right away we see that we have a 20 and a 30 in both of these terms. So when we factor, I want to pull out the biggest number that I can out of both of them. So I can pull a 10 out of the 20 and a 10 out of the 30. So this will be 10 times, what's left after I pull a 10 out of 20 is a 2. So 10 times 2 is the original 20 that I see over there, times x times y plus 3 times x squared. When I pull the 10 out of the 30, I'll be left with 3. Now, there's even more that I can do here. You'll notice that this first one, 2 times x times y, this second one, 3 times x squared, well, x squared is just x times x. And you'll notice that both of the terms inside the parentheses have an x. So x is another factor. So I can pull that out. So if I pull an x out of the first one, what I'm left with is just 2 times y. And if I pull an x out of the second one, I'm just left with 1x remaining. So after I factor this, I'll have 10x times 2y plus 3x. So this would be factored as much as I can. Note that factors don't have to be just single numbers or single letters. So for instance here, it's already obvious what one of the factors will be. I have 2x times x plus 7 minus 3 times x plus 7. Well, the x plus 7 shows up as a factor of both terms in here. So I can pull the x plus 7 out. And what I'm left with, I have a 2x from the first term and a minus 3 from the second. And that's what's left over. So ultimately, this is going to be factored. I can't pull a number out of the second term. There's no common factor of 2 and 3. And even though x is a factor of the first one, there are no x's in the second one. So there's nothing left for me to do here. One more example before we look at a little bit more complicated factoring. Here we have 4 terms, and there is no common factor between each of these terms. The only factors of x cubed are going to be x, x, and x. So I could pull out an x squared, I could pull out an x, but I can't in the 10. The 10 doesn't have any x's in it. So there's nothing I can pull out of every single term here. So what I'll do is I'll group them and pull out numbers that are common to these. So what I'll do is I'll group the first two terms here. We've got x cubed and 5x squared. I'll group those. And what I'll do is I'll group the second ones. So we'll add minus 2 minus 10. Note that I'm just taking these negative signs and keeping them with the individual terms rather than pulling it out. So what's the largest factor? What's the greatest common factor in this first term? Well, I can pull an x squared out of an x cubed, and I can pull an x squared out of the 5x squared. Once I pull an x squared out of the x cubed, I still have 1x left over. And when I pull an x squared out of the 5x squared, I still have 5 left over. So nothing too crazy is going on. Here, I will add, and then I need to pull a factor out of both of these. So what I'll notice is that the first one only has essentially two factors to work with, a -2 and an x. Well, -2 goes into -10, so I'll write this as -2. If I pull a -2 out of this, I'm left with an x. If I pull a -2 out of the -10, I'm left with 5, specifically plus 5, since 5 times -2 is that -10. Now, I'm adding a -2 times something, so I might as well just write this as I will subtract 2 times this. And then finally, I have an x plus 5 and an x plus 5, so I'll pull that out. What I'm left with in the first term is an x squared, and what I'm left with in the second term is going to be minus 2. So ultimately, I have x plus 5 times x squared minus 2, and that may be easier to work with than the fully expanded form at the top. So the last thing that we'll look at in this video is specific polynomials that look like this. This is a trinomial. It has 3 terms, and the terms are going to be a constant term, what's called a linear term, meaning it only has one copy of x, and then the quadratic term, which means that it has an x squared. So it's going to be a times x squared plus b times x plus c. These are really common, and what we'll do is we'll look at essentially factoring this from the perspective of we'll undo FOIL. Remember that FOIL is how we might multiply different factors to expand something, and we'll undo that. So the first thing to notice is that if we can factor ax squared plus bx plus c, what it will look like is something times x plus a number times something times x plus a number. It will be 2 binomials multiplied together to get this trinomial. And in particular, whatever it is that's multiplying the x, when we FOIL, if we take the 2 first terms and we multiply them together, we should get ax squared. So whatever goes into the boxes, when you multiply them together, we should get a. We'll skip ahead to the last terms. When we multiply the 2 last terms in both of our binomials, we'll get whatever c is. So the product of whatever goes in these blanks will be c. The outer and inner ones, when you multiply the 2 outer terms and then the 2 inner terms, we'll be left with terms that have an x in them, and when we add them up, we should get b. So I think the best way to do this is to look at an example. So let's look at x squared plus 13x plus 40. So what I want to do is I want to write this as something times x plus a blank times something times x plus a blank. And I need to know what should go into these terms. Well, the first thing to notice is that whatever product these guys form is going to be x squared. So I need something times x times something times x. So something times x times something times x should give me just x squared. Well, x squared is just 1 times x squared, So the only way to multiply two numbers to get 1 is if they're both 1. So let me update this, and we'll write this as 1 times x plus something times 1 times x plus something. I know that these both have to be 1 because the only integers that I can multiply together to get the number 1 is by taking 1 times 1. We are ignoring fractions and decimals for the time being. So now, whatever goes into these blanks have to multiply together to get the constant term, which is going to be 40. So what pairs of numbers will multiply together to get 40? Well, I could take 1 times 40. I could take 2 times 20. I could take 4 times 10, or 5 times 8. And I believe this is all of the positive ways that I can multiply together to get 40. However, I could multiply -1 times -40, -2 times -20, -4 times -10, and -5 times -8. However, when I multiply those together, I also have to remember the fact that we're going to FOIL, so I'll need to take the outer terms and the inner terms, and those guys should add up to 13. So let's try a couple of these, and we'll see what we get. So if I take x plus 1 times x plus 40, and I FOIL this out, the first terms, the x times x, is just going to be x squared. The last terms, the 1 times a 40, will be plus 40. And what do I get in the middle? I'll have 1 times x. Sorry, I should do this in order. The outer terms first, x times 40, plus 1 times x. And we can see that the inner terms, or the outer and inner term, 40x plus x, does not add up to 13. So this is not the one that we want. And we can continue doing this. I'll do a couple more of these. X plus 2 times x plus 20. Again, we know that the first terms will multiply together to get x squared. The last terms will multiply together to get 40. But in the middle, we'll have 2 times x, x times 20. And then the inner terms, 2 times x. And 20 and 2 do not add up to 13. When you're doing this for the first couple of times, it will seem rather tedious. But the more you do, the more you'll be able to recognize the correct answer right away. So here, the outer terms, 10 times x and 4 times x. And 10x plus 4x does not add up to 13x, but it's close. So we'll scratch that one off, and then the next one should work. 5 and 8. Again, if we multiply x times x for the first terms, we get x squared. The last terms, 5 times 8 is 40. When we do the outer terms, x and 8, we get 8x. The inner terms, 5x. And when we add those together, we get exactly what we want. 13x. So we know that this is going to be the correct pair of numbers, and this is our solution. When we factor x squared plus 13x plus 40, we will get x plus 5 times x plus 8. And I'll do more examples in the next video.